Let's keep going. Okay. So basically from graphs and equations, you can get y as a function of x. Now, a very important concept with functions, as we saw with relations, is the domain. Remember, the domain, that's the collection of all possible inputs for the function. I mean, formally, it's all the possible numbers you could put into the function that yield an output that makes sense. And when I say makes sense, I basically means gives you another number. So it's all the numbers you could put into the function that give you back a number, such that the function gives you back a number. From the graph of a function and from an equation, it can be a little tricky to get the domain. From an equation, it can be. I mean, basically, the rules are as follows. Once you have y in terms of x, the denominators must be non-zero. So eventually it's going to boil down to 3 rules here. You never want the denominators to be 0, right? You never divide by 0. In this class, we never take the square root of a negative number, right? In this class, we don't. Mostly because then you'll get what's called a complex number. And we're not dealing with that. And this is something else. If you have the square root of something, that's what W is. W is an algebraic expression in x. But if you have the square root of something in the denominator, then the domain is all x such that the W is positive. We will do some examples. I know that sounds scary. I understand that. And again, this is so that y is in terms of x. So you want y equal to something in terms of x. So for instance, if you have 1 over x, right, the domain of this is all numbers except 0. Because again, you never want to divide by 0. We already saw y equal to 1 over x. This does give y as a function of x. I mean, here I don't have f of x equal to something, but that's okay. I mean, I had it before. But the domain of this function is all numbers except 0. Here, the square root, as I said, you never take the square root of a negative number. So in this case, the domain is all numbers that are non-negative, which as an interval is this. I mean, again, there's different notation people use. Some people just write y equals something or f of x equals something. But here we're dealing with y as a function of x. What about this one? The domain, well, again, here we have a square root. We want all x such that the radicand here, what you're taking the square root of, is non-negative, right? So in this case, we want all x such that 3x minus 5 is bigger than or equal to 0. So we get those inequalities again we have to deal with. Okay, that's not so bad. We just solve an inequality for x, right? So what do? We get x all alone. We add 5 to both sides. We have 3x bigger than or equal to 5. Now again, we don't want 3x, we want x. So we divide both sides by 3. And we get x greater than or equal to 5/3. Okay. X greater than or equal to 5/3. I don't know why I put 3/5 there, but let me fix that. Yeah.
So how did you solve that? Like how did you take the radicand out?
We want the domain, so we want to make sure the radicand is greater than or equal to 0, right? Because again, you never take the square root of a negative number. So basically 3x minus 5 for the domain, we never want 3x minus 5 to be negative. In other words, we want 3x minus 5 to be greater than or equal to 0.
So how did you take away the, maybe I'm saying the wrong, is it the radical?
The square root symbol?
Yeah,
Well, for the domain, we can ignore it because we know that what's under it has to be non-negative. That's all we care
you can
about.
just take it off.
Yeah, for this problem, you can.
Okay. All right, thank
Okay,
you.
you're welcome. Because remember, the input is x. Well, excuse me. Yeah, we could just disregard the square root sign. Okay. And again, does that make sense or?
Yeah, thank you.
You're welcome. So basically, again, we're looking at what's under the radical, right? So the radical symbol we can really ignore because we want to know when the radicand is non-negative, right? If this can't be negative, then it has to be greater than or equal to 0. So that's what we're doing here. We're solving this inequality, and we get x greater than or equal to 5/3, which means the domain is all x such that this is true, right? We want the domain, it's all x such that 3x minus 5 is non-negative. So we had to solve this. And by what we did, by solving it, we get this occurs when x is bigger than or equal to 5/3. So this interval is our domain. Okay. Does that make sense to everyone? Let me just say this quickly because we're close on running out of time. But this is, well, yeah, well, you know, we'll do this next time. So what I'm going to do is I'm going to start from this slide next time. So, okay, we'll start from here next time. So let's stop for now.